Good morning, those who are watching my video. And before going to the topic, I would like to request all of you to subscribe the channel if you have not subscribed it yet. You will have the advantage of seeing all the videos of 12th standard and prepare well for your board exam. And this is what I am going to take is VBT part 2. And those who are not seen valence bond theory part 1, please see that and come back and see this video so that you will understand, you will have the clear idea about the concept. Clear? So in the last class, as a recapitulation, I am telling, in the last class you have studied the hybridization and the shape of the complexes whose metal atom has a coordination number of 6. And they have, the hybridization will be two types, either D2sp3 or sp3d2, and this shape will be always octahedral. And today I am going to take the VBT theory, that is valence bond theory of the complexes, in which the central metal atom has a coordination number 4. So let us start the topic with an example. That is this example, nickel. As a central metal atom, nickel, I will take nickel Cl4 two times. Let us take this example. So the first step is to find out the central metal atom, which is a central metal atom. Nickel is the central metal atom. And we will find out the oxidation number of nickel. So how to find out the oxidation number? Once again, I am reminding you. We know that chlorine is coming in halogen group. So chloride's valency will be 1. So oxidation number, as it is a non-metal, its oxidation number is -1. So I will write -1 into 4 equal to -4. Now, suppose nickel's oxidation number is X. X plus -4 should be equal to the total charge 2 minus, that is -2. Now, X is equal to -2 plus 4 equal to +2. So, nickel's oxidation number here is +2. Now, what is the next step? Now, you should understand that nickel's coordination number here is 4. Okay, so the next step is to find out the electronic configuration of nickel, then nickel 2 plus. So first we will write the electronic configuration of nickel. Nickel atomic number is 28. So the electronic configuration will be 4s2 3d8. So now we have to find out the electronic configuration of nickel 2 plus. 2 electrons will go. From where it will go? This 2 electron will go. So we will get, as a result, we will get 4s0 3d8. Now we have to write the orbital configuration. Orbital configuration, when I draw, you know that nickel is coming in the fourth period. Okay, so we have to write the orbital configuration where this is 3D and D subshell has 5 orbitals. Then 4s is the and 4p also is the. Even though 4d also is the, it is not useful here, so that I am not drawing 4d here. Now, we know that in 3D, how many electrons are there? 8 electrons are there. So, these 8 electrons I am going to write according to Hund's rule of maximum multiplicity. 1, 2, 3, 4, 5, 6, 7, 8. So, you can see that 2 unpaired electrons are there. Okay, now next we should understand that the ligand chlorine, here the ligand is chloride. Chloride is a weak ligand. I will give the chart of weak and strong ligands at the end of this video. Okay, chloride is a weak ligand. So what is the problem? A weak ligand cannot pair up the electrons. So these two electrons will not be paired up. These two electrons will not be paired up. They will stay as it is. Okay. Now in presence of a weak ligand, what will happen? I'm again going to draw the orbital configuration. And you should know one thing. The complex here, what I have shown is NiCl4. coordination number is 4. Okay, so that detail also you will write here. Coordination number of central metal atom is 4. So if 4 is the coordination number, you should understand that 4 chloride ligands are surrounding nickel, and this 4 chloride ligands will give electrons to nickel. Clear? So nickel should be able to accept the electrons from chloride. How many chlorides are there? 4 chlorides. So nickel should have 4 hybridized orbital. Here, 4 hybridized orbital means 4 empty individual orbitals should be there. Which are the 4 empty individual orbital? 1, 2, 3, 4. So, these are the empty orbitals. So, what will happen? Once again, I am drawing. This is 3D in which 3 are paired and 2 are not paired. Next is 4s and next is 4p. These three, these four orbitals will get hybridized. Hybridized means they will mix up to get hybridized orbitals of same energy. So the hybridization is 1s orbital, 3p orbitals are the, so the hybridization is sp3. This is the hybridization. So our first question's answer you got sp3 hybridization. Now if sp3 hybridization, the shape of the complex will be tetrahedral. So shape will be tetrahedral. Then what is the next question? Whether it is inner or outer orbital. As d orbitals are not involved, there is no question of inner or outer orbital. Okay, those who have not seen the last video, please see that and come. Then only you will understand all this. Then next question is magnetic character. Magnetic character. What is the magnetic character? The last video I explained what is the magnetic character. If there is unpaired electrons, the complex will be paramagnetic. So this is a paramagnetic complex. So in short, I can say that this complex is sp3 hybridized tetrahedral and paramagnetic complex. I hope you understood this. Now let us see another one. I'm just scrolling up. Those who want to see the video, again you can rewind and see the video. Next, I will write another one, that is nickel. Another example, that is NiCN 4 times. Cn is cyanide 4 times 2 minus. What is the difference here from the last complex? The ligand has changed. That is, it is Cn minus. And you should understand a very important thing. Cn minus is a very strong ligand. It's a very strong ligand which can pair up the electron. That is the difference. So again we will write nickel. We have to find out the oxidation number. Oxidation number, we know that Cn is Cn minus. So you can write that minus 1 into 4 is equal to minus 4. Nickel, if nickel is x minus 4 is equal to minus 2. That is this total charge. And x is equal to minus 2 plus 4 is equal to plus 2. So here also nickel's oxidation state is plus 2. So we will find out the electronic configuration of nickel. First you will write, then nickel 2 plus you will write. So first nickel 28. I am repeating the same thing what I have done for the last complex. So nickel 28. Nickel 28 will be 4s2 3d8. Then nickel 2 plus will be this 2 electron will be removed. So you will get 4s 0, 3D, 8. Then what should I do? I should draw the orbital configuration. Orbital configuration will be 3D, 3D, and here 4S is the, and we have 4P also is the, right? Now 3D8. 3D8, according to Hund's rule of maximum multiplicity, I can write 1, 2, 3, 4, 5, 6, 7, 8. Clear? Now, next, we should understand that we remember the CN is a very strong ligand. CN is a very strong ligand. You can write this in a column so that you will never forget it. Okay. CN is a very strong ligand. So what CN will do? CN will pair up this electron. So what will you get? In the presence of ligand, that is a strong ligand Cn minus, you will get the configuration like this. This will also get paired up. This is already paired up and this also will get paired up. And we have 4s empty and we have 4p empty also. Now we know that the the coordination number is coordination number 4. Coordination number 4. That means what? 4Cn minus will give electrons to 4 empty orbital of nickel. For that, nickel should have 4 hybridized empty orbital. For making 4 hybridized orbital, 4 individual orbitals should be there. Which are the 4 individual orbitals here? See, this is an empty individual orbital. This is another one. This is another one. This is another one. So we have an hybridization like this. This is 4p. So the hybridization here is, this is 3D children. So from 3D, 1 orbital, from 4 is 1, from 4p 2. So we will have dsp2. See, d1 and s1 and p2. So this is another special type of configuration for whenever there is a coordination number of 4. So we have dsp2 hybridization. Hybridization dsp2. Now, whenever there is hybridization dsp2, the shape will be square planar. Square planar. Now, inner and outer 3D is involved because inside d orbital is involved. It is a inner orbital complex. Inner orbital complex. Then what is the next question? Next question is whether this is a paramagnetic or diamagnetic complex. That means we have to find out the magnetic character. What is the magnetic character? You can see here no single electrons are there. All the electrons are paired up. So naturally this complex is a diamagnetic complex because there is no unpaired electrons. So you can understand two things from today's video, that one minute children, two things you can understand from this, that when the coordination number is 4, there can be two hybridizations. What are they? Two hybridizations. The first one is sp3 and the second one is dsp2. And when sp2 sp3 hybridization is the shape will be tetrahedral. And if the hybridization is dsp2, the shape is square planar. Okay. Now I told you in the end of the video I will give you this all the list of strong and weak uh, ligands. So we will see which are the a chart I will give you. You can write it down. The strong ligand. The strongest one is carbon monoxide, which is known as carbonyl. Next is Cn minus is also very strong. Then ammonia is strong. Then EDTA is strong. EDTA4 minus is strong. Then NCS minus, that is cyanate, thiocyanate also is strong. Then we can see some weak ligand, and C2O42 minus also is strong. Okay, then weak ligands. Weak ligands, see all the halogens, that is halides are weak. That is easy to study. All the halides are weak. Then S2 minus is weak. Then OH minus is weak. Then H2O also is weak. So thank you so much for watching the video. Once again, I'm reminding you to subscribe the video and press the bell icon. And next video, I will take CFP, that is crystal field theory. Till that, bye.